So if we think about, maths, natural numbers. So natural numbers. Now within maths, they like to use letters or symbols for all of these different concepts. So natural numbers are donated by an n, okay? N for natural and natural numbers. So what are natural numbers? So natural numbers, they can also be thought of as counting numbers. So if we think about n, so what are all the natural numbers? So they're equal to, just as an example, so we have 1, 2, 3, 4, 5. Okay, and this goes on forever to infinity. So these here are examples of natural numbers. Okay, and sometimes they're called counting numbers. Because if you think about it, you use them to count things. Like if I was to say to you, how many hands have you got? Okay, you're going to, or how many chairs, for example, are in the room that you're in. What you're going to do is you're going to count the numbers, and you're going to represent that value with a natural number. So you might come back and say, for example, there are 5 chairs in the room. Okay, things like how many days in the week are there, that's going to be represented by a natural number or a counting number, 7. How many months in the year, 12. Okay, so these are all they're numbers basically that we use to count, okay, or to count things. You can also have what are known as consecutive natural numbers. So if we think about the word consecutive, so if we think about, for example, the days of the week, so you have Monday, followed by Tuesday, followed by Wednesday. Okay, these are consecutive. One follows after another. If I was to say to you Tuesday, Monday, Friday, these are non-consecutive. They do not follow one after another. So what we mean by consecutive, we mean that they follow one after another. So what we can have also, we can have consecutive natural numbers. Okay, so you can have consecutive natural numbers. Like if we think about these guys up here, so these here, 1, 2, 3, 4, 5, 6, 7, these are what are known as consecutive natural numbers. So they naturally follow one after another. And that's what it means in relation to natural numbers. It means they follow one after another. So you have consecutive natural numbers. Natural numbers then as well, they can be split up into two kind of main groups, let's say. So you have natural numbers. So you have natural numbers. Okay, and then they can be split up. You can further split those up then as well. So you have you can have odd numbers, and then you can have even numbers. So odd and even numbers. So if we think about the odd numbers, for example, like if we think about the numbers, let's say, so these are natural numbers, so 1, 3, 5, 7, and 9. So these will be classified as odd numbers, because if you take these numbers and you try and divide them by 2, so if I take 1 and divide it by 2, for example, so if I take 1 and I divide it by 2, what's that going to be equal to? So we'll just get a calculator. So 1 divided by 2, so it's equal to 0.5. 0.5. If I was to take 5, for example, and divide it by 2, it's going to be equal to 2.5. Okay, so what's happening is these numbers are not dividing evenly. Okay, so therefore they're known as odd numbers. So basically, an odd number is any number that when you try and divide it by 2, it will not divide evenly. You'll have this remainder that's left over, like we see here with these two examples. So these are what are known as odd numbers. So odd numbers, these are examples of odd numbers, and odd numbers will not divide evenly by 2. Whereas on the other hand, if we think about the following, so if we think about the numbers, so 2, 4, 6, for example, so these numbers, they're natural numbers, okay, they belong to natural numbers, but if we divide these by 2, so let's say if I take 2 and I divide it by 2, that's going to be equal to 1. If I take 4 divided by 2, that's going to be equal to 2. And if I take 6 and I divide it by 2, that's going to be equal to 3. So you can see here that all of these numbers, they divide evenly with each other. They divide evenly by 2, whereas these ones don't. Odd numbers don't divide evenly by 2. When you divide them, they won't divide evenly by 2. Whereas if you take even numbers, they will divide evenly by 2, as we can see here. So 2 divided by 2 is 1, 4 divided by 2 is 2, 6 divided by 2 is 3. So these are what are known as even numbers. So you have natural numbers, they can be split up into odd numbers and even numbers. Odd numbers will not divide evenly by 2, even numbers will divide evenly by 2. Okay, now a really good way to represent natural numbers is this thing that we call it a number line. So let's have a look. This thing that we call a number line. Okay, so let's think about this idea of what's known as a number line. So what we can do is we can draw a line like so. And we can use this number line to represent our natural numbers. So we'll call this, let me just rub out some of this so we have some space. So I'm just going to rub this out here. So we have this idea of what's known as a number line. So a number line, so for example, we can start here from 0 and we can put a point. Okay, so this is 0. And then we can make divisions along this number line like this. We'll just make one more. And then this number line will travel indefinitely over in this direction here. So what we can say is we can put our natural numbers on a number line. So you have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so these are what are known as a number line. And you can see here that they're roughly equal distance apart on this number line. And again, it can be just a way to visualize numbers or counting, for example. Like you might think in your head, when you're counting, for example, you might have a number line like this, and you'll say 1, 2. So when you're counting in a consecutive way, so when you're moving, what's happening is you're moving up the number line. Okay, so you're going 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you're moving in this direction. Now, what's also useful as well in relation to this, we can use this for adding and subtracting, for example. So let's say if we want to add and subtract natural numbers. So let's say if I take the number 2 and I add 1 on to that. Okay, we know that that's equal to 3. Now, a way to think about this on the number line. Let me deformat some of this so we can work with this. A way to think about this in your mind is to say, so let's say the number that's on the left hand side is 2, so we start off here on the number line at 2. When we're adding, we're moving to the right on the number line. When we subtract, we're moving to the left on the number line. So if we take this case, so we're adding, so what we're doing is 2 plus 1, so we're adding, so we're moving one place to the right. So we're moving, remember with addition, we move to the right. Okay, so addition, we're moving to the right. Subtraction, we're moving to the left. So again, we move one place to the right. And we end up here on 3. Similarly, if I take, imagine I have 7 minus 2. So what's happened is this number tells us where we start off. So we start off at 7. We have minus here, the operation subtract. So we're minusing, so we know we're moving to the left. And how many places to the left do we move? We move 2 places to the left. So you have 1, 2. So where are you ending up? You're ending up on 5. So 7 minus 2 is equal to 5. So this is the idea or the concept of what's known as the number line. So that's our number line. Okay, so I think we've covered a lot in this class. So let's have a look. So we talked about natural numbers. Okay, so natural numbers. The symbol that we use to represent natural numbers is the n. Okay, these are examples of natural numbers, 1, 2, 3, 4, 5, and this goes on to infinity, it goes on forever. So another way to think about them is they're counting numbers. And you can have consecutive natural numbers, so these are examples of consecutive natural numbers. So one follows after the other, they're known as consecutive, just like the days of the week, Monday, Tuesday, Wednesday, and Thursday. If we take our natural numbers, then they can be split up into 2 groups. You have odd natural numbers, which, for example, these are examples here. And when you try and divide them by 2, they will not divide evenly. And then you also have even natural numbers. So these are numbers like these ones here. When you divide them by 2, they will divide evenly. And you'll have no remainder left. Then we talked about this idea or the concept of what's known as the number line. So the number line can be used to represent your natural numbers. So you can put them on a line like so. So you have 1, 2, 3, 4, 5, 6, 7, 8. And this here indicates that this line goes on indefinitely in this direction. So it goes on forever, right on to infinity. We also kind of talked about like adding and subtracting, how you can visualize this, let's say, on a number line. So for example, if you 2 plus 1 is 3, so you're starting off at 2. When you're adding, you're moving to the right on the number line. When you're subtracting, you're moving to the left on the number line. So in this case, it's 2 plus 1 is 3. So you start on 2 and you move one place to the right because we're adding, and you end up on 3. Likewise, we've 7, so we start off on 7 over here, and we minus 2, so we move 2 places to the right. So that's natural numbers and that odd and even natural numbers and this idea of what's known as the number line. Okay, thank you for listening.